Next, we are starting the new topic, that is the center of mass. Center of mass. So now we are starting the new topic, the totally new chapter, that is called the center of mass. देखो center of mass में हम क्या कैलकुलेट करने वाले हैं. हमें अभी तक हमने जो पढ़ा है, we have studied about the work power energy, we have studied circular motion, we have studied projectile motion, we have studied all. But center of mass is a special point to be discussed in a body for the motion of a body. Means whenever the motion of a body is going on, then the center of mass is very helpful to calculate the different types of quantities related to the motion of a body. So we will study in such a way the center of mass. Center of mass of the system, sometimes we can calculate center of mass directly by just seeing the system. But sometimes we have to calculate the center of mass. We have to calculate the position with the center of mass location. So these are the things that we will discuss. So let's start with the center of mass position. पहले बताते हैं center of mass की importance क्या है. देखो center of mass is a special point discussed during the motion of body about which motion of body can be easily discussed. Like let's suppose there is a ball that is doing the projectile motion. And let's say it is rotating. Right? So it is revolving as well as doing the projectile motion. Now if we have to calculate the different points related to the motion of it, like जैसे मेरे को मान लो इसकी रेडियस ऑफ कर्वेचर निकालनी है, या मेरे को इसका रेंज निकालनी है, मेरे को इसकी मैक्सिमम हाइट निकालनी है, तो वी कैन नॉट कैलकुलेट इट डायरेक्टली. हम उसको डायरेक्टली फाइंड आउट नहीं कर सकते. हमें क्या करना पड़ेगा, देखो वी हैव टू रीड द मोशन ऑफ अ बॉडी अबाउट सम स्पेशल पॉइंट व्हिच इज द सेंटर ऑफ दिस बॉडी. which is the center of the body, जो इस बॉडी का सेंटर है. तो दिस इज द बेनिफिट टू रीड द सेंटर ऑफ मास. क्योंकि अगर हमको इस बॉडी का सेंटर ऑफ मास पता है कहां पर है, तो वी कैन इजीली रीड द सिस्टम विदाउट नोटिसिंग द अदर पॉइंट्स ऑफ द बॉडी. हम सिर्फ इसके सिस्टम के सेंटर को कंसीडर करके उसकी बाकी सब पैरामीटर्स को कैलकुलेट कर सकते हैं. इज इट क्लियर? तो दैट इज अ बेनिफिट टू कैलकुलेट द सेंटर ऑफ मास. वी कैन कैलकुलेट इन सच अ वे. Is it clear? लिखेंगे इसको. Yes, please. Yes, next is to locate the position of center of mass. Yes, देखेंगे. Position of center of mass. First of all, I am discussing the position of center of mass for a discrete system. For discrete system. देखो, let's suppose these are the different masses lying. This is M1, this is M2, M3 and so on. This is the position vector of M1, which is R1. Position vector of M2, which is R2. M3, which is R3. So we can say RCM. It is the position vector of center of mass. We can say this is M1 into R1 plus M2 into R2 plus M3 into R3 divided by M1 plus M2 plus M3 and so on. मतलब RCM vector is summation of Mi Ri by summation of Mi. अब RCM वेक्टर होगा क्या? RCM वेक्टर इज XCM I cap plus YCM J cap plus ZCM K cap. Now what is XCM? Summation of Mi Xi by summation of Mi. What is YCM? Summation of Mi Yi by summation of Mi. What is ZCM? Mi Zi by summation of Mi, right? So in this way we can calculate the position of the center of mass for the discrete system. For continuous system, we can say here masses are continuous, then discrete. So the RCM will become integration of RDM by integration of DM. Similarly, XCM will become XDM by integration of DM. YCM will become YDM. ZCM will become by integration of DM. Right? Like, look at the example related to it. I am taking for discrete system first. 4 masses of M1 is equal to 1 kg, comma M2 is equal to 2 kg, M3 is equal to 3 kg, and M4 is equal to 4 kg. Are lying at the vertices of square of side 1 meter as shown. Locate position of center of mass. M1 is how much? 1 kg, 2 kg, 3 kg, 4 kg. Consider this to be the origin. This is 1 meter. This is, let's put, lying along the x-axis, and this is lying along the y-axis. So it will become 1, 0. It will become 1, 1. It will become 0, 1. So what is RCM? This is M1 into R1. Plus M2. This is the answer for it. Is it right? So in this way we can calculate the position of the center of mass for the given system. Is it clear? So this is the system of the discrete masses in which we have calculated the center of mass of the discrete system considering one of the mass at origin. Like if I have considered the mass, this is at origin, and my position of center of mass to be calculated it as, that is half I cap plus 2 by 5 j cap. So this is the position. So in the discrete system we will do like this. Is it clear to all of you? So this is the way to solve the discrete system. Clear? तो अभी की हमने इसमें पढ़ लिया कि अगर हमको कंटिन्यूअस सिस्टम दिया होगा तो उसके लिए हमें कैसे सेंटर ऑफ मास लोकेट करना है, और अगर हमें कोई डिस्क्रीट सिस्टम दिया हुआ है तो हमें उसका सेंटर ऑफ मास कैसे लोकेट करना है. सो राइट डाउन दिस. यस. नेक्स्ट, फर्स्ट ऑफ ऑल आई एम टेकिंग सेंटर ऑफ मास फॉर टू पार्टिकल सिस्टम. फॉर टू पार्टिकल सिस्टम. अब दो पार्टिकल सिस्टम के लिए हम सेंटर ऑफ मास देखो कैसे डिफाइन करेंगे. इसका बहुत इंपॉर्टेंस भी है क्योंकि बहुत सारे क्वेश्चंस हमारे इससे डायरेक्ट सोल्व होंगे. देखो ये M1, दिस इज M2. लेट्स सपोज दैट दिस सेपरेशन बिटवीन देम इज D, और दिस इज द पोजीशन ऑफ द सेंटर ऑफ मास which is at a distance d1 from there, and d2 from there. If I consider it to be origin, so we can directly write here what is axiom? It is M1. Yeah, what is RCM? This is M1 into 0 I cap plus 0 J cap plus M2 into D I cap plus 0 J cap. मतलब it will become divided by M1 plus M2. So it will become M2 into D divided by M1 plus M2. This is RCM, I cap. So means it is axiom. M2 into D by M1 plus M2. That means the position from there is so here D1 is M2 into D by M1 plus M2. Now, and what is D2? D2 is D minus D1. D minus what is D1? This, it will become M1 plus M2 into D minus M2D, that is M1D by M1 plus M2. This is the value of D2. If you judge directly, you can say कि this is M1 into D1, here M1 into D1, it is equal to M2 into D2. m1 into d1, it is equal to m2 into d2, right? So this is the point. Now next, center of mass of continuous systems. Center of mass of continuous systems. Like for first one, center of mass of uniform rod. For a uniform rod, it will become like this. Right. Let's suppose it has a length L and its mass is m. Let's suppose this is the coordinate 0, 0. And by moving x distance from there, cut the dx. For dx, the dm is m by L into dx. So what is the center of mass? So what is the center of mass? Center of mass will become xcm, integration of x dm over में integration of dm. So what is the value of xcm? It is equal to integration of x dm. And what is dm? M by L into dx divided by integration of dm. And x is varying from 0 to L. M by L into x dx. Integration of dm is m. By putting limits, it will come out to be xcm will come out to be L by 2. Will come out to be L by 2. right? Center of mass of uniform circular ring. Mean this is the case. For a uniform circular ring, its radius is r, mass is m. So center of mass is this at the center O. That is the center of mass for the uniform circular ring. Center of mass of uniform semicircular ring. This is a semicircular ring. Cut it dm from there. This is O. This is the dm. Which is r d theta. M by L. L in how much? 2 pi r. Pi into r. Its radius is r. Circumference. Into r d theta. That is m by pi into d theta. तो मैं क्या लिख सकता हूँ हियर, जो इसके लिए हम dm लिख सकते हैं. What is the r vector? This is r cos theta I cap. Plus r sin theta j cap. This is the position of dm. ये हमारे पास dm है. This is dm. The position of dm. that is r cos theta I cap plus r sin theta j cap. So what is RCM? That is integration of r dm over the integration of dm. dm is m. What is the integration of r dm? dm. What is dm? Integration of r dm. Integration of dm is m. What is dm? m by pi into d theta. m भी बाहर निकलेगा, सिर्फ पाई भी बाहर निकलेगा, d थीटा अंदर रहेगा, तो ये बन जाएगा m by pi. इंटीग्रेशन ऑफ dm is m, d थीटा अंदर रहेगा. इट विल बिकम r cos theta I cap theta j cap into d theta. Theta is varying from minus pi by 2 से plus pi by 2. What is the integration of r cos theta? What is cos theta? That is integration of cos theta is sin theta. And what is the integration of sin theta? Minus cos theta. That is cos theta I cap, r cos theta I cap. Wait, it will become r sin theta I cap. Sorry, because we have cut the theta there. That is r sin theta I, r cos theta j cap and r sin theta. That will be r sin theta I cap plus r cos theta j cap. Similarly, it will become r sin theta I cap plus r cos theta j cap. That will become cos theta, that will become minus cos theta. That will become sin theta. And is 0. Sin pi by 2 is 1 and this is also 1. So it will become 2. So that will come out to be 2r by pi j cap. That is the center of mass of semicircular ring. Position of center of mass of semicircular ring. That is 2r by pi. So 2r by pi somewhere here. Having coordinate 0, YCM. 1 cm is 2r by pi. The next is center of mass of disk. यूनिफॉर्म डिस्क है तो इसका सेंटर ऑफ मास तो उसके सेंटर पे ही होगा. Center of mass next of semicircular disk. To derive the center of mass of it, you can go with y, and y पे जाके you can cut the dy. And then you can write the center of mass of the ring. Integration of ydm divided by integration of dm. What is dm? Into what is the area of this? Into dy. If you will solve it, y varying from 0 to capital R, you will get 8r by pi. 4r by 3 pi. Right? Next, सॉलिड स्फीयर और जो हमारे पास सॉलिड स्फीयर है या फिर जो हमारे पास होलो स्फीयर है, उनके केस में भी उनके सेंटर ऑफ मास जो होंगे वो सेंटर पे रहेंगे इफ इट इज यूनिफॉर्म, बट व्हाट इज द सेंटर ऑफ मास ऑफ दैट इज अ हेमिस्फेरिकल बाउल, दैट इज अ होलो हेमिस्फेरिकल बाउल. For the hollow hemispherical bowl, the center of mass will lie at r/2. Solid hemisphere. Its mass is m, radius is r. So its center of mass is at 0,3 r/8. Right? Write down the problem. Calculate center of mass of given systems. We have the first system as these are the 4 rods and each having the mass m and length L. Another one is the system. This is the system. These are the rectangular plates. This is the point 0, 0. This is the point L, 0. This is the point 0, L. L by 2, 0. L by 2, L. And these are having the massive like this. It is having mass M. And this is also having mass M. So these are the three plates basically. And each having the mass M. इससे हमारे पास ये सिस्टम है. These are the four rods and we have to calculate the center of mass of the system. Now we know that for the single rod, the center of mass of the single rod will lie at its own center. If we consider it to be 0, 0, this point will become, this point will become, this point will become, and this will become. So we can say what is RCM. Each having the mass M. R1. R1 will become, means we can consider for this system, these continuous system, we can consider their masses to be at the center of mass of the given rod. Means we can consider center of mass of the each rod, mass of each rod to be at its center of mass, right? तो हम देखो क्या कर सकते हैं. It will be M into L by 2 I cap plus M into L I cap plus L by 2 J cap M into L by 2 I cap plus L J cap. Zero I cap plus L by 2. And what is the total mass? 4M. So these M and M will cancel out. This is L by 2 I cap plus L I cap plus L by 2 I cap plus this. That will become 2L I cap. M cancel out हो जाएगा. 2L by 4 I cap प्लस अगर मैं बाकियों को निकालूं तो इट विल L by 2 J cap plus 2L by 2, 2L by 4 J cap. L by 2 I cap plus L by 2 J cap. So this is the answer. Now look at this system. In this system also we can consider the each mass of the whole to be at their own center of mass. मतलब मैं इसमें भी क्या कर सकता हूँ, मैं इसके अंदर भी हर जो हमारे पास प्लेट है उस प्लेट के मास को उसके सेंटर ऑफ मास पे कंसीडर कर सकता हूँ. So these coordinates will come out to be L by 4 comma L by 4. Comma L by 4. Comma 3L by 4. Right? So RCM will come out to be M1 into R1. Plus L by 4 J cap. Total mass is 3m. This is L by 4 plus L by 4. That is L by 2. That is 2L by 4. That is 5L by 4. Four into 3, 12. I cap. This is the value of RCM. Right? Next question. A disk of mass m by 4 is cut m by 4 and radius r by 2 is cut from a uniform disk of mass तो दोबारा लिखो जी uniform disk has mass capital M and radius capital R. a disk of radius r/2 is cut as shown in figure. Calculate center of mass of remaining system. This is the disk to be cut. ये कट कर लिया. So this is the remaining mass. This is the remaining mass. देखो इसको क्या करने का तरीका होता है. अगर इफ ये मास भी प्रेजेंट होता, मान लो मैं इसको बोल देता हूँ m1. अगर टोटल मास होता है m1 और m2 तो क्या होता, तो हमारा जो सेंटर ऑफ मास होता वो ओरिजिन भी होता. मतलब तब आरसीएम कितना होता है, that is 0 i cap plus 0 j cap अगर m1 और m2 दोनों होते, राइट. लेकिन हमारे यहाँ पर m1 m2 दोनों नहीं है, we have just m1. तो मैं इसको कैसे करूंगा, सबसे पहले हमें पता है आरसीएम होगा क्या, m1 r1 प्लस m2 r2 डिवाइड बाय m1 प्लस m2. देखो सबसे पहले तो m1 कितना है, तो हमारे पास m1 प्लस m2 है, उसका नाम m है, टोटल मास. इट इज इक्वल टू सिग्मा मास पर एरिया. राइट. एंड व्हाट इज m1, m2 सिग्मा इंटू इसका मास, इसकी रेडियस इज r/2 बाई r²/4. तो व्हाट इज m1, थ्री बाई फोर पाई r². This is the value of m1. And what is the center of mass of r2? m2 का center of mass कहाँ पे होगा, r2 is the center of mass of m2. So what is the RCM? देखो पाई r² और सिग्मा ऊपर नीचे से कैंसिल हो जाएंगे कॉमन लेने पर, पाई आर स्क्वायर और सिग्मा ऊपर नीचे से कॉमन लेने कैंसिल हो जाएगी। यहाँ क्या बचेगा m1 के लिए r1 हमने निकालना है, इसके लिए क्या बचेगा m2 के लिए व्हाट इज r2 m1 प्लस m2 1 बचेगा। व्हाट इज द वैल्यू ऑफ r1 वेक्टर r by 8 I cap this is the value of r1 vector, that is minus r1 minus r by 6 I cap। मतलब इसका जो सेंटर मास आएगा it is at the position r by 6, right? That is at this location minus r by 6 comma 0। लिखो इसको, yes।